Hi guys, today we want to prove that if y equals x raised to n, then integral of x raised to n dx will be equals x raised to n plus 1 divided by n plus 1 plus constant of integration. Now, let's say proof. So now, recall from this expression that we have here, we have y equals x raised to n. Now, when we find the first derivative of this dy dx, we have it to be dy dx will be equals this one, this n will come here, then we have x raised to n minus 1. Now from here we can cross multiply. When we cross multiply, now we have this, that the y will be equals n x raised to n minus 1, then we are going to have it to be the x. So now from here, substitute the value of y that equals x raised to n here. So what we are going to have is d into bracket of x raised to n will be equals n x raised to n minus 1 all divided by the x. So now from here, by putting n to be equals n plus 1, so we are going to have this to be d into bracket of x raised to n plus 1 will be equals, here as well we have it to be n plus 1, then we have x. For this n, we have it to be n plus 1, then we have minus 1, then we have it to be the x. So we have it to be the x. So now from here we have d into bracket of x raised to n plus 1, and this one will be equals n plus 1. Then we have this to be x. This we cancel this, we have it to be x raised to n, we have it to be the x. So now from here we can divide both sides, or we can say divide both sides by n plus 1. So this implies that from here we have d into x raised to n plus 1 divided by n plus 1. Then this one will be equals n plus 1 divided by n plus 1. We have x raised to n, we have it to be the x. We believe that this will cancel this out. So what we are going to have is d into bracket of x raised to n plus 1, then this one divided by n plus 1 will be equals x raised to n, we have it to be the x. So from here we can now have, by the time when we take the integral of both sides, so when we take the integral of this, we are going to have it to be integral of d into bracket of x raised to n plus 1 divided by n plus 1 will be equals x raised to n, we have it to be the integral of this, we have it to be the x. So we believe that this integration and this will cancel out. So we are going to have x raised to n plus 1 divided by n plus 1 will be equals integral of x raised to n, we have it to be dx. So therefore we have integral from here x, we have integral of x raised to n, the x will be equals x raised to n plus 1, we have it to be n plus 1 plus c. That is, since this integration is it's an indefinite integral, so we need to put constant of integration to it. And that is the proof for that. Bye.